And welcome back. This is our Lunch and Learn. My name is Leslie Potter, and I am the administrator here at PMsquare. So feel free to grab a lunch or a snack, depending on the time where you are. There's also a poll that you can feel free to respond to at any time over on the right-hand side there. I just want to remind us all of our session giveaway. This time, one attendee in this session will be randomly selected to receive this Shark robot vacuum valued at $230. I personally have this device and it is magic. And then don't forget to provide session feedback after each session to increase your chance at this year's Bacon 2021 Grand Prize, which is our indoor-outdoor theater kit. So on to our Lunch and Learn. Chris Chen is a data engineer here at PMsquare. Chris has nearly 20 years of experience in the consulting, financial, benefits, healthcare, manufacturing, and education sectors. He has used a wide array of BI and DW software, including Cognos, Glue, SSIS, Informatica, and of course, Excel. In his personal life, Chris claims to be extremely boring. His hobbies include documentaries, volleyball, and terrible dad jokes. So in this pre-recorded session, Chris will discuss and demonstrate how to fulfill your ETL needs with AWS Glue, a serverless, scalable ETL tool that enables you to discover, clean, combine, and store your data in AWS, allocate the resources you need for your ETL jobs, and pay only for what you use. And then at the end, Chris Chen will join us live for a Q&A.
Today's Lunch and Learn, Serverless ETL with AWS Glue. I'm Christopher Chen, and I'm a data engineer here at PMsquare. In fact, today's my second anniversary. I've been working with ETL, data warehousing, and business intelligence since 2005, and today I'm happy to show you AWS's serverless ETL tool, AWS Glue. Today, I'm going to talk to you about the AWS Glue Architecture, which starts with the Glue data catalog, which is populated by Glue crawlers, ETL jobs in Glue Studio, and custom ETL jobs with just plain Glue jobs. Let's start with the AWS Glue architecture. Here's a simple diagram of the AWS Glue architecture. The main component is the data catalog, which keeps the metadata information of all the data stores. Next comes the AWS Glue crawlers, which connect to the data stores and gather all of the metadata information from all tables or files and saves it to the data catalog. Next, we have the Glue jobs, which take the information from the Glue data catalog, use it to connect to sources and targets, and perform any transforms in the middle. Crawlers and the ETL and Glue jobs run on the Glue ETL structure, so there's no need for you to provision your own servers. Here, I'm going to show you a sample database that we're going to be using. It's been provided by IBM's Cognos tool called Goal Sales. It's the sales from the Great Outdoors stores. We're going to focus on 4 tables: the product name lookup, product type, and order details. Let me show you what we're talking about. Here is our SQL Server, and I have the Go Sales database listed here, and I'm looking for the order details table, the product table, the product type table, and the product name lookup. Product has the product number, base product, product type code, and those are the 3 things that I'm going to be looking for in the product table. In the product name lookup table, we have the product number, the language, of the description and the product name. In the product type category table, we have the product type code and then a number of different fields for the language, for the product type in a number of different languages. Finally, we're going to be looking at the order details, which has the quantity, price, and cost for all of the products represented by the product number, and the ship date and order number for each order. Now let's go and look at the Glue data catalog. The Glue data catalog, as I said, is the repository of all data object definitions. Tables and columns from either databases or from CSV files stored in an S3 bucket would be stored, that metadata would be stored in the repository. To begin our project, we're going to be creating a new Glue data catalog. We're going to name it GoSalesDB, and that's what the Glue crawlers, where the Glue crawlers are going to be saving the metadata. Here is the Glue console, and in the Glue console, I have no database here, so I'm going to be creating a new database. I'm going to call it GoSalesDB, and as you notice, AWS Glue likes things in lowercase, so it automatically changed that for me. And I'm going to say metadata database of all GoSales objects. And now it's created the GoSalesDB, and it's got the description. When I click on it, it'll say I can edit or delete that, and then it'll have something for the tables. Now, I have not run a crawler yet, so there are no tables in GoSalesDB. The Glue data catalog holds two kinds of objects: databases, which we just created, which has names and formats of columns that are from database tables or files, and then connections, which are JDBC connections to databases, or S3 connections, which are names of S3 buckets, which would hold files. So I've already created two JDBC connections, one to the GoSales tables and one to the GoSales results tables, which is where we're going to be storing the results of our ETL. You do not create a JDBC, you do not create a connection to the S3 bucket. Your jobs and tables have a pointer to the S3 bucket contained inside them. So let's go and look at the JDBC connections that I've already created. Back in our Glue console, we have connections of JDBC type. I've created one for GoSales, which is a JDBC connection in the SQL Server, and then it points to a RDS implementation on AWS, and then connects to a specific database, in this case, GoSales. There's networking information about the VPC and subnet and security groups. And then there's a username, PM2 admin, and a description. This is something I can edit, but it's not something I want to because I've already tested it. In fact, I can show you the test results. I give it the role, and it'll tell me that it's testing my results, testing my data connection. Now you'll see that It has returned success for the connections. The other connection that I have is the Go Sales results, which has almost exactly the same JDBC connection info, except the database is Go Sales results. Same VPC and subnet and security group because it's connecting to the same server. Same username as well. So those are the two connections. And now we're going to go to creating our glue crawlers. Glue crawlers connect to either databases or files in S3 and gather the column information from each of them. These can be either source or targets, and the results of the crawlers are saved in the data catalog. Glue crawler sources can be either databases or S3 files. When you're connecting to a database, you give it the database name, the schema, and the table name. If there's any extras that you don't want to connect to, you would use an exclude pattern, and anything that matches that pattern would be omitted. In an S3 file, instead of the database name, you would give it the S3 bucket name or the name of a subfolder inside the bucket. If there's a large number of files and you just want to use a few of them as a sample, you can give the connection up to 149 files. And like in a database connection, you can exclude some files by inputting an exclude pattern, and anything that matches that will be skipped. So let's go and create a couple of database crawlers. The first one we're going to look at is the Go Sales database, and we're going to add everything that's in Go Sales and all the tables underneath it. A %sign is a wildcard, and the crawler is going to find multiple schemas. So let's go ahead and do that. Here we have in the Glue console the crawlers, and we don't have any crawlers yet, so we're going to add one. And this one is going to be the Go Sales crawler. We're going to give it a description. We don't have it. We're not interested in any security configurations, and we don't have any custom classifications. Let's go to our next. Crawler source type is going to be a data store, and because we're going to a database, the S3 data stores options here don't matter. Here's our data store definition. We're going to be using a JDBC connection, and our existing connections is the Go Sales connection, and our include path, as I mentioned, is the Go Sales database and everything in it. Don't want to add another data store. Here's our security role. And let's run on demand. And we're going to put all this in Go Sales DB. We don't want to have any prefix attached to it. We're going to update any data definitions that are already in the data catalog, of which there aren't, but that could change in the future. And anything that's already in the data catalog that we don't find with this crawler, we're going to delete. So here we have our crawler configuration information, and let's say finish. And our crawler, Go Sales crawler, is ready to run. So let's run that. You'll get something saying that it's attempting to run it. and then it says it's running. You'll get your status information here, starting, and then it'll tell you some progress, usually in minutes. Then once it's done, it'll say stopping, and then ready. Here's the result of our crawler. Go Sales crawler took approximately 5 minutes and added 70 tables, which is a little interesting. It might be more than we're expecting. Let's take a look at our database again. We have a lot of tables in the Go Sales schema, but it doesn't look like we really have 70 here. So what could it be that it's looking at? Could it be that they're using that it's retrieving the Go Sales HR or Go Sales MR or RT schemas? Let's take a look at our Glue catalog and see what it's found. So in our tables, here's all the tables that I've found. So there's the Go Sales database, Go Sales HR schema, and then the organization table, and it's all in the Go Sales DB database in the data catalog. So Go Sales HR, and organization, it's in our SQL Server. So it looks like what we want to do is we want to exclude everything except the Go Sales schema. So what we can do is go back and modify our crawler. Right now it says an include path of everything in the Go Sales database. We can either specify a specific schema that we're looking for, the Go Sales schema, or we can add all of the other schemas that we don't want as an exclude path. Let's go and just add Go Sales. That'll be simpler for us. Crawl all folders. No. Here's our include path. So let's add the Go Sales schema, and then we'll take every table under the Go Sales include path. Say next, next. Frequency is run on demand. We're going to add to the same database. Here's our include path, database, schema, all. And we finished it. Now, let's run our crawler again. Crawler is running. Take about 5 minutes. Okay, our updated gross sales crawler has finished. It says it's returned 0 tables and 0 were updated. Let's see if it actually did what we wanted it to do. Let's check our tables. And it seems that all the other schemas were not included. So the crawler didn't say that it deleted them, and it didn't say that it added anything, but it has done what we wanted. So let's go and add the Go Sales results database tables. Let's create another crawler. Go Sales results crawler. Don't have anything that we need to do here. Next. Once again, we're going to JDBC connection, but this time going to Go Sales results, and the include path will say Go Sales results. Let's try everything again. Add another data store. We don't want to. Our security role. We'll run it on demand. We'll save it to Go Sales DB. Everything looks the way we want it. We'll say finish, and it's created. Now let's run that crawler. There are many tables in Go Sales Results, so it should be fairly quick. We see now that our Go Sales Results crawler has completed in about 4 minutes, and it's added 4 tables and updated none. So let's take a look in our Go Sales DB database for any of the tables that it found. We have DBO final results, DBO product name lookup, DBO product, and DBO order details, and those are the 4 that we have in our database. So our crawler has completed successfully. Now let's create an S3 crawler to look in our S3 bucket AWS Glue Bacon 2021. I've added 2 subfolders, source and target, so our bucket and subfolders should be saved into the data catalog by the S3 crawler. So we'll go to our crawlers. We'll add a 3rd crawler. We'll call it Go Sales S3. We're going to crawl. Now this S3 data store comes into play. We're going to crawl all folders, and this is going to be a new data store. Here we're looking at an S3 data store. It's not going to have a connection. It's going to use a specified path. Here we can actually browse for it. We know we have AWS Glue Bacon 2021 with source and target underneath it. So let's select that. We don't think we have much in the way of files, so we'll leave that alone. We don't have any exclude patterns, so let's say next. Don't need to add another data store. We're going to choose a role that already exists, and we'll run this on demand and store it in Go Sales DB. We'll say next. We'll say finished. And let's run that crawler. Here we see that our S3 crawler has finished. It's taken about 54 seconds and added 2 tables. Let's see what it added. Go back to our tables, and we have 2 tables that are classified as CSV files. Product type CSV, product name lookup CSV. If we look at product type, we'll see that the location is a CSV file in an S3 bucket, and we have 3 columns in the schema: product type code, product line code, and product EN for English. Those are big int, and string. One thing to note is that Glue does not use an exact database data type. Things that are varchar in a database are strings in Glue. Let's also look at what we have in our Go Sales database tables. Here we have our Go Sales product. It's in the use the Go Sales connection. Its location is the Go Sales database, Go Sales schema, and product table name. We have 9 columns, 1 through 9, with product type code, product numbers, product image, timestamp, and color code. These are integers, a string, 2 timestamps, and another integer. If we look at our tables in the Go Sales Results database, we can see that the final results table has 5 columns: product type code, quantity, product type name in English, and total cost and total revenue. We're going to be calculating total revenue and total cost by multiplying the quantity and the unit cost and unit price to get our total. And our product type code, we're going to be grouping it by product type code, and we'll have the name of the product type code here in the string. Our S3 crawler is finished, so let's review our Glue data catalog. Our crawler results returned tables, which are coming from either SQL Server or S3, and returning our name, a description, and what database. And the location of each table is either in a database schema in table or the bucket in subfolder and the file name. One thing to note is that table schemas returned by Glue Crawler can be edited. I can add a column with a specific column number to insert it in the middle. I can change the column name and type, and I can delete columns. Let's say in our Go Sales database, we're going to look at the tables, and we're going to edit the product type CSV table. So we have our 3 columns here, and we're going to edit the schema, and we're going to add a column. We'll say this one is product line name. We'll make that a string, and we'll make this the 3rd column. We'll add that. So now product line name that we added is now column 3. I can take product type EN, and we'll make that English. Or I can just decide, you know what, I don't want that column, and we'll delete it. And if we decide we didn't want to keep those changes, we can cancel, go back, and everything is the same. Now, let's get to AWS Glue Jobs. If you'll remember, Glue Jobs are where we do the bulk of our extract, transform, and loads. The easiest way to do Glue Jobs is using the graphical tool AWS Glue Studio. It has a graphical interface. You have a canvas where you can drag nodes that do certain Glue functions. And if you need to, there's a code editor if you need to do any custom Python scripting. Let's create a basic Glue Studio job where we're pulling from the product table in Go Sales, and we're going to store the results in the product table in Go Sales results. Here in our Glue console, on the far left sidebar, we have the ETL section where Glue Studio is the first entry. We will click on that and get to the Glue Studio homepage. On the far left is a button for View Jobs. When we click on that, we come to the Glue Studio Jobs page. We have not created any jobs here, so none are listed. Our options for creating a job are to do direct script editing, either Python shell or Spark, or we can create a visual job that has a canvas with a source and target already existing, or we can do a visual job with a blank canvas and author, and we can write everything ourselves. Let's create a canvas with a source and target already. Source and target can be chosen down here. We mentioned we were going to be doing it from a database of Go Sales, and we're going to be saving it to Go Sales results. In both cases, we need to use the Glue data catalog. So let's create. Now we've created a blank canvas. Now we've created a canvas with data catalog table for the source and the target. So let's configure that. In our source, we have the database Go Sales DB, and we're going to be retrieving Go Sales product. Let's put a name in here. And these are the columns that are going to be returned. And let's go back to the data catalog table for the target. Still go sales DB, but the table is go sales results product. And our input schema in this case. And let's put a name in our go sales target dot product. Those are updated in the source and target nodes. Now let's look at our apply mapping transformation. In this case, we have all of the columns in both tables. And if we want, we can change the source and to match a different target. If we wanted to, we could switch introduction date to be discontinued date and discontinued date to be introduction date. This does not help us much in this. It does not help us much in this job since we are looking to make sure that everything goes straight across. So let's save our job. And it notices that we have some job details that we need to fix. Our job needs a title. Load product. Need to give it a security role. And let's leave this for now. We'll explain this later. And we'll save it. It's creating the job. Let's go back to our jobs, and we have load product. Click on that to reopen it, and we can say, let's run this job. Click on runs, it says it successfully started it, and we can go and look at the runs, and we have started it, and our run status is running. It'll take a few minutes to run. Here we see that our job finished in approximately 2 minutes. So let's go back to our jobs homepage and let's look at our database to see what the results look like. Here we are back at our SQL Server database. And let's look at our Go Sales product table. See that we have 274 rows. And let's look at the same on our Go Sales results. And once again, 274 rows. So we've successfully transferred product from Go Sales to product in Go Sales results. Before we start working with more complex Glue jobs, let's take a deeper look at the Glue architecture. Glue is based on the open source Apache Spark infrastructure. Spark is a cluster of Java virtual machines that are deployed as worker nodes. Each worker has at least one executor that processes tasks and data sent to the worker node. Spark supports the Python and Scala languages and has a library that understands a subset of SQL functions. The Spark Cluster Manager receives requests from the Spark driver containing data and either Python or Scala code. The code is compiled into Java bytecode by the cluster manager, and the data and bytecode is then passed to the worker nodes. Each worker node runs the Java bytecode in its own Java virtual machine and processes the data and passes the results back to the cluster manager. That data and results are passed back to the Spark driver and then to the requester. The main data structure of Spark is the data frame, a collection of data without any data type information. This is similar to a database row, which is described by a separate table or DDL definition. Processing a data frame requires two passes. The first one to infer the data structure, and the second one to apply the data format to load the data. AWS Glue uses a different data structure, the dynamic frame. A dynamic frame is similar to the data frame, but includes its own schema, allowing it to be self-describable. This allows the dynamic frame to be processed in a single pass. Dynamic frames with different schemas can be part of the same collection, and the nodes in Glue Studio understand the dynamic frames and can process them natively. There are more code libraries that support the manipulation of data frames than of dynamic frames, so AWS has included the ability to convert a dynamic frame to a data frame and vice versa. Existing data frame specific code can process the converted data frames, and then Glue can convert the data frames back to dynamic frames for Glue specific code manipulation. Now that you understand that, we can move on to custom scripted Glue jobs. A Glue custom job is created from the Glue console, not Glue Studio. The entire job is Glue custom job is created from the Glue console, not in the Glue Studio. A custom job is all scripted code, either Python or Scala. I've divided most of my Python scripts into 4 sections: initialization, extraction, transformation, and loading. To create a Glue job, go to the sidebar, click on the Jobs link, and click on the blue Add Job button. This will bring you the Configure the Job Properties page. Give the job a name. In our case, we're going to create a job that calculates the revenue and cost from the order details job from the order details table in GoSales. Going to add our service role. We're going to make sure this is a Spark type of job. We're going to make sure that we're using Glue version 2.0 with Python 3. I'm going to create a brand new script. The script file name is going to be calculate revenue and cost. The script is going to be stored in the Glue scripts directory in S3, and any temporary files will be in the temporary folder. Advanced properties, we're going to disable the job bookmark. Job bookmarks allow for incremental loads. In monitoring, we want to make sure that we see job metrics and any continuous logging. We're not going to put any tagging information. We're not going to use any security configurations. We don't have any special libraries or Java jars, so we're going to leave those blank. Our worker type, we're going to use G.1x, which is one virtual CPU and 8 GB of memory. If we're looking for something that needs more, we can switch to the G.2x, which is 2 virtual CPUs and 16 GB of RAM. We don't need that much processing power, so we'll stay at Glue at G1.x. The number of workers you saw in our architecture diagram, we don't need that many because we don't have that much data. So we're going to put it down to 3 workers. The fewer number of workers, the less money that you will spend on a glue job. We're going to have only one of these glue jobs running at the same time, so our concurrency will be 1. The job will not run for that long, so we're going to have a short timeout. The default is almost 2 days. We will probably only need 10 minutes. We're not going to have the job retry if it fails. And that's all the configuration information we need on this page. We're going to be connecting to both Go Sales and Go Sales results, so we need to include those connections. We're going to save our job, and then we're going to start editing. Let's begin our scripting with the initialization phase. I will cut and paste my code for the initialization phase. We start off with importing the datetime Python module, importing Python modules for PySpark. Then we bring in the Python modules for Glue. And then here we start initialization of our context and sessions. So we create a Spark context, then we create a Glue context on top of the Spark context, and then we create a session on top of the Glue context with us using the Spark session. Underneath this, we have the parameters. I like to set parameters for our Glue database and database tables, and our target database and target database tables. As much as possible, I try to make them descriptive of what they contain, with a prefix that describes what they're doing. So for a database, I will put src for source database, and we know our source database is GoSalesDB. And inside GoSalesDB, the product table is GoSales_GoSales_product. Our product type is GoSales product underscore type, and our GoSales order details is GoSales order details. This you will find, these should match the definitions that are in the data catalog. And then I have 2 variables for the target. The target database is the same, our GoSalesDB, and then our final results variable is GoSales_results, DBO for schema, and then final results. The second phase is the extract phase, where we read the data from the database table definitions and store them in dynamic frames, and then we take those dynamic frames and convert them to data frames. So here you see we are retrieving using the Glue context and the create dynamic frame from the data catalog. We're using the source database, which we've set to Glue, set to GoSales_DB. We're pulling the table name is GoSales_product, and the transformation context is a unique identifier for this particular transaction. We do the same for the GoSales product. For the GoSales product type, where we use the same database variable, but we change the table name to Go Sales Product Type, and we have the same identifier for our transformation context. The same goes for our Go Sales order details. And now that we've read those three tables into dynamic frames, we're going to use the 2df to convert them to data frames. So we have a data frame variable here that's using the read method for using the 2df method to copy the data from Go Sales Product, Go Sales Product Type, and Go Sales Order Details. As much as possible, I like to put a little bit of debug information that will show up in the job logs. So I like to take the Go Sales Product, I like to take the table name, and I like to take the data frame that it refers to and print out a count of rows that will show up in our logging information. I also like to do a show of the first frame, for the first record in that frame, and I'll put it in the vertical format and make sure that it has a maximum of 50 characters. So I'm doing that for Go Sales Product, for Go Sales Product Type, and for Go Sales Order Details. And I'll show you this when we run our job. To reiterate, the first phase of the custom job is the initialization phase, where we import the Spark and Glue libraries, including one for SQL functions, initialize our context and sessions, and set our parameters for source and target databases with the metadata information from the data catalog. Our second phase is the extract phase, where we load the data from the source tables into dynamic frames and then convert them into data frames. The third section is the transformation session. I'm going to be creating a variable that's going to hold a SQL statement, and there are two ways to issue that SQL statement. You can either send it directly to the database using a JDBC connection, or you can query the tables in memory. You can load the data frames that you've already loaded from the database into memory and use them in the from or join clauses in your SQL query. In both cases, results are returned as new data frames. Here in our script, I'm going to be pasting the transformation section. I print a little thing to the log file saying that we're going to be loading data frames into temp tables. So we take our Go Sales Product data frame and we use the Go Create or Replace Temp View and function, and then we name it Go Sales Temp Go Sales Product. We do the same thing with Go Sales Product Type and Go Sales Order Details. Now that we've loaded the data frames into memory, I log a message that we're going to be starting our SQL query. Instead of saving the SQL statement in a variable, in this case, I'm passing the SQL query directly to this session, and we'll restore the results. We'll be storing the results in the results data frame, results_df data frame. Our statement is a select of product type code, product type English, quantity, total revenue, and total cost from, and PySpark's SQL functions can handle subselects. So I'm doing a subselect here from Go Sales Product that's an inner join against Go Sales Product Type to get the product type code and English name, and joining on product type code from product and product type, and then also joining in the Go Sales Order Detail table, which matches product number from product and product number from order details and close the subSQL. And we're going to group by product type code and product type English name and order by the English name. And these three quote marks close the statement. I've surrounded this by a try and except to do exception handling. If there's anything wrong, it's going to print the exception results. Once this is done, I have it set up to print a subset of the data frame to the output log. It's going to print a count of the rows in results DF, and it's going to show the first two records in the results DF in vertical format and truncated to 50 characters wide. The next section is the load section, where we write the data out to database tables. Here in our load section, we take the results DF data frame and we convert it back to a dynamic frame and store that into the dyn write results dynamic frame variable. To do that, we need to take the data frame up using the glue context that we created and use the dynamic frame from df method. The results are in dyn write results, and then we take that glue context and write a dynamic frame from the catalog definition. The frame is dyn write results, the target database, the target table name is target final results, and the transformation context is write results. I print a note to the log saying that we've loaded, and then in the log print the end time. And that's our entire job. If we save this, we can run the job immediately. If there's any parameters that we wanted to change, we could do that here. I'm going to keep them as is. Now we can watch here in the logs tab the lines that I print out to the log file. Here we see that the message to the log file saying the start time has been printed. Here we see that Go Sales product was loaded with 274 rows. Go Sales product type was loaded with 21 rows. And Go Sales order details was loaded with 446,000 rows. Then the SQL query is run, and we can tell that the result is 21 rows. And in all of these cases, at least one record was printed out. So we can look in a different log file to see those in better detail. Here we have our end time. So this job has completed. We can see the run job is no longer rotating, so it's completed. If we like, we can go to the jobs in the Glue console, and we see that we've selected calculate revenue and cost. The job has succeeded. The startup time was 17 seconds, and the execution time was 10 minutes, and our timeout, if it exceeded 10 minutes, it would have timed out. The files that I printed out to the logs are in the output file. This opens up AWS CloudWatch, which holds the log files. CloudWatch is opening up AWS Glue Jobs output. There are 3 log files that matches the three workers that we've configured. And the one with no suffix on it is the main worker. So here we have all of the log files, all of the lines that were printed out to the log files. Here we have our start time. Here we have our 274 rows to gross sales product. Here we have the one row from gross sales product that we've printed out. Product number, discontinued date. This looks good. It matches what we expect from gross sales product. Gross sales product type is 21 rows. And we can see the first row of gross sales product type code, product line code, the English version of the English name for this product type, and then the names in other languages. Then in our next log line, we have the rest of this this record has overflowed the record line, so CloudWatch adds the fields to the next row. Now we see that our gross sales order details is 446,023 rows. This is our first record from that table. Order detail code, order number, unit cost, unit price, unit sale price. We've loaded all of the data frames here into temp tables, and we will run our SQL query. The results of the SQL query is 21 rows, and we will look at the first two rows of the result set. Product type code of 963, binoculars. We have 1,075,087 binoculars were sold. This is the total revenue and the total cost. And in our last row, we have loaded the target final results and the stop time. Let's go to our database and see whether or not we did an insert. So in our Go Sales Results database, we have the VBO final results table. Let's make sure that we're querying the right database from final results. And here we go. Our product type code, our product type English name, quantity, total cost, and total revenue. So that's how we do a custom job in Glue. So our transformation, we did the issues of the query, and in our load, we converted the data frames back to dynamic frames and wrote those to the target tables. I talked a bit about the configuration settings, the Glue version, required connections, bookmarking, tags, and monitoring, the Python library path, the worker types, the numbers of workers. There's also the concept of a Python shell Glue job. It's a Python environment that doesn't use the Spark libraries. You have a custom Python script. It does not use the same amount of workers that a Spark job would normally use. These jobs will be used for SQL statements that you want to send to the database, or other, pretty much just that. I have jobs that truncate tables before we do ETL, or after jobs have been After the data has been loaded, it refreshes materialized view. So let's wrap this up. We did our AWS Glue architecture. We showed the Glue data catalog with the metadata, Glue crawlers that populate the metadata, some simple Glue jobs in Glue Studio, and a custom Glue job. I hope this was helpful for you, and let's see if we have any questions.
All right, we do indeed have some questions. We're now joined by Chris Chen live.
Hello, everyone.
First question here. Can I use an external scheduler with AWS Glue?
Yes, you can. There are ways for you to use an API to call the Glue job, or you can also use the AWS command line interface. You'd have to set that up on your machine.
Okay. Why should I use AWS Glue instead of my favorite ETL tool?
Well, chances are your favorite ETL tool would need to be installed on a machine, either on your local machine or on an EC2 instance at AWS. AWS Glue, on the other hand, is serverless, so you would not have to do any local or cloud installation. You just run it. You just run it natively. So chances are it's going to be cheaper and it's going to be faster.
Okay, great. Do I need to learn Python to use AWS Glue?
Technically, no, but practically, yeah, you're going to need to. You can do a lot in the AWS Glue Studio, but if you're going to need to do anything like a custom transformation to do any calculations, you would still need to insert some Python code in that Glue Studio job.
Okay. Is it possible to develop Glue jobs remotely instead of in a browser?
Yes, Glue allows you to create a development endpoint. The endpoint, once you create the endpoint, it essentially sets up a server in the background for you, and you can connect your Python interpreter or a SageMaker notebook or a Jupyter notebook. You can connect that to that development endpoint and do your development that way. One thing to worry about, one thing to note is you are billed for the time that the development endpoint is running. So when you close down your development environment, you need to make sure that you close down the development endpoint. Otherwise, it's going to keep running until you tell it to stop.
Okay, good to know. How do I know how many DPUs to give an AWS Glue job?
Okay, so this DPUs are the amount of processing power that you're going to give it. Each DPU, if you remember the Spark diagram that I talked about earlier in the presentation, each of those worker nodes underneath the Spark cluster manager, that's a DPU. The more DPUs you give it, the more worker nodes that you have. There's a diminishing returns if you might want to give it, say, 60 DPU because you think you've got a lot of processing power. You've got a lot of data that you need to crunch. But if you give it too many, you're just going to be spreading out a very thin layer of data to a lot of worker nodes that really aren't going to be doing that much. So you want to size it appropriately. Some of it could be trial and error. You can run with a medium-sized number of nodes of DPUs, and then tune it up and down based on your testing.
Okay, perfect. I think that was the last question. So thank you so much, Chris, for this
Sure.
awesome Lunch and Learn. All right, so we have some upcoming sessions. Next up at 2:30 in the enablement track, we have Architecting Cognos on AWS presented by PMsquare. And then our final sessions of Bacon 2021 at 3:30 Eastern. Enablement, hands-on with Amazon QuickSight presented by AWS. And then the execution, creating custom visualizations in Cognos presented by PMsquare. And then also just want to let you know that Chris has a Genius Bar session on Cloud ETL coming up at 3 o'clock Eastern. So if you'd like to talk one-on-one with Chris, make sure you head on over and set up an individual time. And look forward to seeing you at our next sessions. Thank you so much.